singularity to me is defined by the aperture or the magic circle at the center of the vortex. Okay, I don't subscribe to a singularity that gets that is a solid at the center of a black hole.
Mm-hmm.
I believe everything has to have a hole at the center, a nozzle.
Mm-hmm.
Okay, and matter can never reach the very epicenter. Matter can only define by going around the lip of the vortex well. It's the same as a hurricane, same as a tornado, same as a water spout. It makes a funnel. Okay?
Mm-hmm.
There always has to be a hole in the center. If it's not there, it'll block up. It'll have stomach shutdown. It'll stop flowing.
Mm-hmm. Mm-hmm. Okay.
It'll become a log jam.
Right. Okay. All right. Let's see. Well.
Excuse me for 1 second.
Yeah.
Put that cat down. No, let that cat sleep. Goodbye. Out of here. I'm back.
Oh, it's funny. All right.
Yeah, this cat gets carried all day.
The cat's like, oh my gosh, give me a break here.
Yeah.
Well, one of these days she'll learn a lesson. I don't lift cats much. I've been scratched too many times. All right. Marko, what about... Okay, let's talk a little bit about applications some more.
Okay.
People can listen back to this program and the previous couple that we've done. They can start to play around with the mathematics themselves and determine that the descriptions of what you're saying are real things that are happening in physical space with the numbers. So people can convince themselves of that outside of... Now, you've done a great job of explaining it, and it's difficult stuff to try to get through. But back to applications, and for example, applications for individuals. Do you think that people should just be grabbing a hold of this, use the math, use the geometry, and do cool stuff with it?
Well, we know, except for people who've come to Hawaii who have been my students, and there's people who've applied it through personal instruction who've worked with me, we know that there's very little available to the general public, unfortunately.
What do you mean?
It hasn't been deliberate, but...
What do you mean there's very little available?
Well, if you go to my website, there's only really just one page. You have a quick introduction. We literally fly through the explanation to how we got to the torus.
Right.
Then there's the executive summary, which is almost...
That's the PDF,
more of a discussion than with a few endorsements. But, I sent you, Mike, something that I with tooth and claw, resist sharing, and that I fight with people to not give them that I've been asked for all the time.
I know. You sent me your book, essentially.
You were able to just open that up just now?
Well, I've got it. I've got the two big RAR files, but unfortunately on the computer that I don't have a RAR converter.
A RAR.
Yeah.
You can download it in a second. You just go to CNET, type in RAR under downloads.
Well, I'll tell you what I'll do.
It's the same as a zip thing, except that you just have to download a RAR.
Yeah.
Compression software.
The problem is I got to do it while I'm on the air with you.
I know.
But...
And dance the Magdalena at the same time.
Yeah, at the same time. But what I would... Well, with your permission, I mean, I still want to put the stuff up.
I don't want to put that up. Here's why. I'd rather, if we're going to put it up, I'd rather do it on another evening.
All right, that's fine.
Go through each image slowly, and I'll do a one-sentence description. It would probably be more like 20 sentences. But the point being is that it's too encumbering, and it's too much of a pain in the butt.
Without you to be able to describe it at the same time.
Well, look at the verbal...
Yeah, the language is overwhelming, yeah.
Yeah.
Yeah, that's what you were saying before. Well, let's do that then. We'll plan another program, and we'll have you walk us through it. And
then you'll host it, if you don't mind, on your site.
Yeah, I'd be glad to. I apologize. I just didn't have the time tonight to get it open and converted.
Not you, it's me. I didn't send it to you till about an hour and a half before the show. It took me a while to compress them and get them in order. You have 169 different JPEGs there.
Well, I appreciate you sharing it, and I'll not do anything with it without your permission.
For the audience, can I describe what you're looking at, just mentally?
Yes,
what
please.
You have there is you have cross sections of the donut. You have top-down views, bottom-up views, 60-degree angle views, surface topology views.
And this is the remarkable thing: is that it's not just on the surface of the torus. This is throughout the entire the structure, all of it.
By my own pronouncement, my own statement, I am the first man alive who can accurately model 3D space. Okay, which incorporates the distance from the axis, expand the inverse square law, how everything moves. Okay, how everything compresses and decompresses. I obsolete the Cartesian coordinate system. I have found the true XYZ system. Yeah, what you're describing to everybody there, which you are dumbfounded by, which is astounding, is that I am able to tap into the Z-axis tangentially to anything, everything. Okay?
Mm-hmm.
I call it the dandelion puff principle. I am able to go into the interior, as Russell Blake says, when he did the mathematical formulation of the Rodin torus, and he started writing articles, he said he was able to mathematically model the interior volume of a torus. You know?
Mm-hmm.
Nobody has a math other than unless they're my students and have learned this, that can start looking at the internal volume of things.
Mm-hmm.
Okay, 100% accurate, okay, reflecting its motion, past, present, and future. You know, I have found the light.
Expand on that, Marko. Talk about that a little bit more, the relationship to time. In other words, you said, past, present, and future. How does the geometry relate to time? And speaking of time, I'm going to ask you about what the hell you think is going on this planet and what's 2012 all about and all this, if you have any opinion on that. But please, let me not get ahead of ourselves.
I'm flattered that you would solicit my opinion. Okay. I can see beyond a septrillion. I can actually do a freeze frame slice view of time itself. In conventional technology and physics, when they do cryogenics, when they try and freeze light, nobody has ever arrested or stopped motion of light or matter 100%.
Right, they've slowed it down, but
they approach zero.
Mm-hmm.
They never reach frozen state, absolute zero. Okay?
Mm-hmm.
I'm able to do it because I do what I call a mathematical interferometry, a mathematical diffraction grating. In other words, I know it sounds so confusing. I'm able to take, I think, if I don't sound confusing enough, I'm not there. I'm going to pull up somebody who described it well. His name was, he wrote a book, hold on for a second, Godo Escher-Bach.
Escher-Bach?
Godo Escher-Bach. He was the closest, there's two descriptions that come really close to my work. Here it is. It's written, this is by Douglas Hofstadter. And what he's postulating here is exactly what I claim to have done. He says, quote, "It is clear that we have all hardly scratched the surface as far as formal systems go. It is natural to wonder about what portion of reality can be imitated in its behavior by a set of meaningless symbols governed by formal rules. Can all of reality be turned into a formal system? In a very broad sense, the answer might appear to be yes. One could suggest, for instance, that reality is itself nothing but one very complicated formal system. If symbols do not move about